All right, guys, so in section 9.1, we were adding and subtracting polynomials. In 9.2, we are going to be multiplying polynomials, and it's a big deal concept. Some sections are little sections. I know you won't use them much later on. This section is a big deal section. It's going to come up. It's going to have huge implications for us in the rest of the chapter. So, multiplying polynomials. All right, essential question. How do I multiply polynomials? Easy. The key principle here is distribute, and we have seen distribution before. So for example, example 1. Notice here, I am multiplying a one-term polynomial or a monomial with a four-term polynomial, okay? So I'm multiplying that first guy with these next four. And it looks like distribution, right? So what I'm going to do is I'm going to multiply in every single term. Distribution. We have to use exponent laws. So for example, when I do 2x cubed times x cubed, I need to use good exponent laws here. You know to multiply the coefficients. There's the invisible 1. 2 times 1 is 2. And add the exponents. So x to the 6th. So I have 2x to the 6th. Okay, great. Now we'll do this next one. Again, multiply coefficients, add exponents. This is going to be 6x to the 5th. Next term, multiply coefficients, -4, add exponents, x to the 4th. Finally, 5 times 2x cubed, 10x cubed. Very nice. I should look to see if I have any like terms in my new polynomial. Maybe there's something I can simplify, but definitely all the exponents are different. No like terms. This is my final answer. So this is something that we've seen before. Distribution, easy. But what happens if I'm multiplying, so multiplication, what happens if I'm multiplying a binomial, a polynomial with two terms, by another binomial? This is tricky because I no longer have just one thing to distribute in. How am I supposed to do it when there are two terms in each parenthesis? Well, this is where we will need to use a really awesome, fun technique. I think, honestly, it's one of the funner things you do in math, and it is called FOIL. FOIL is a cleverly crafted acronym that stands for firsts, outers, inners, and lasts. So here's what we're going to do. Every term that's in the first binomial is going to distribute to every term in the second binomial. Let me show you what this looks like. X times 3x. This is the first term in each binomial. This is my first. So x times 3x is 3x squared. Then I'm going to do outers. So that would be the first term times the last term. Notice that it's like the outers, okay? So x times 2, that's 2x. Now notice this x is now done. It has multiplied every other thing in the other binomial. So I'm done with it. But I need to move on to this -4. And I need to rainbow it in to everything in the second binomial. So -4 times 3x. Notice how this is the inners. -4 times 3x. This is going to be -12x. Finally, I have my lasts. I need to multiply -4 times 2. Notice that this is the last term. -4 times 2 is -8. Okay, so I put every term into every other term. Nice. The x went into this and this. The 4 went into this and this. I've used up all the terms, I'm good, and drawing these rainbows can really help you organize your work. Now, as always, I need to check my new polynomial to see if there's anything that can combine, and if you notice, these middle two terms are both x's, so let's combine them. That'll be -10x. So I have 3x squared minus 10x minus 8. Oftentimes when you do FOIL problems, these middle two will combine. That's a common feature, so keep an eye out for that. And speaking of keeping an eye out for things, let's look at example 3. That transition made absolutely no sense. Okay, we're going to use the FOIL acronym again. So I have a binomial times a binomial. I need to put every term into every other term. So first, we'll take care of the 4n times the n. This is the first. Whoa, 4n times n, 4n squared. Remember, I'm multiplying coefficients, adding exponents. Next, The outers, 4n times 5, 20n. Drawing the rainbows helps me keep myself organized. Now I realize I've used up the 4n. It has gone into everything in the second parenthesis. So now I'm doing the inners. I'm starting with the -1 now. -1 times n, just -n. Finally, the last, -1 times 5, -5. Notice I have put now -1 into everything in the other parenthesis. Everything has distributed to everything in the second parenthesis. I'm good to go. And just like the last one, I need to combine these middle two terms. 20n minus 1n is 19n. Then I have 4n squared and -5. Wizard, Annie. That's a quote from episode 1, my least favorite Star Wars. All right, so last example. Like I said, this is a big topic. This one and this one are huge. This one, slightly less huge, also slightly more complicated, but you do need to know how to do it. Notice, this is a trinomial. Tri because there are 3 terms. So it's 3 terms times a binomial, which is 2 terms. So I can no longer use first, outer, inner, last, because look, if I do the firsts, okay, x squared times 3x, maybe I can do outers then, but like what's inners? Is it the 6 or is it the 7? I'm confused. So what I need to remember is this general principle. I need to distribute each one of these terms into each one of these terms. So let me show you what that means. And again, if you use the rainbows, we'll be good to go. X squared, it needs to go to the 3x, so 3x cubed. I'm multiplying, remember. Also, the x squared needs to go to the -4. So that's -4x squared. And just a reminder, because I'm a great teacher and I repeat things, multiply the coefficients, add the exponents. Multiply the coefficients, add the exponents. Okay, notice I have now used the x squared up. X squared, it has gone into this, it has gone into this. It's done. Next, I need to move on to the 6x. 6x times 3x is, I think, 18x squared. Be really careful about your work here. Next, 6x times -4, -24x. All right, so now I've used the 6x up. Finally, I need to move on to the -7. -7 times 3x, -21x. -7 times -4, +28. All right, now I have a lot of like terms to combine here, but first, before we do, notice I put the x squared into every other term. It went to 2 terms in the second parentheses. Same with the 6x, it went to both terms. Same with the -7, it went to both terms. Great. My pen is making gaps when I circle. Look at this. Look, I cannot circle. It's, okay, just kidding. That was a perfect circle. Yay. Anyway, I need to combine like terms. 3x cubed, it is sad and lonesome, just like I am making this video. These next 2 terms, 14x squared, they're happy. These, I think that's -45x. And then I have the sad little constant term at the end, 28. Wow, it was a 3rd degree polynomial, which makes sense because my first term, x squared times x, ended up as x cubed. All right, well, that is multiplying polynomials. Remember, the key feature is when you're multiplying 2 polynomials, you have to distribute or multiply every single term in the first polynomial with every single term in the second polynomial. So problems like these, we could use that nice FOIL acronym, but problems like these, we had to use the general principle of distributing everything into everything else. Thank you for watching, and I kept it short this time, so you're welcome. See ya.